I've just briefly spoke to Ian before we started the call as to how best to get the use out of this next 45 minutes. I think the best way to do that is if we table the options and talk through what the options are, and then we can understand from you, Dom, as to what concerns, questions, or just comments that you want to make on each of those. And then hopefully, I'm a massive believer in face-to-face conversation. I think that the written word can be interpreted in a tone that you want to read it in, or everything else. I think let's have a conversation about it, answer any questions or clear up any misunderstandings, and then hopefully by the end of this 45 minutes we'll have a way forward. But equally, please understand there's no pressure, Dom. You don't have to agree to anything on this call. You're fine to go away and have any conversations or further thoughts, or even come back to us at a later date with any other questions that you've got. You're not under any pressure on this call at all. This is more to outlay the options to you and answer any questions that you've got. Does that make sense? Now, I'm just going to start by clearing up. So we've discussed on email this morning about option 3, about there being 3 options. So
Joe, just before we go into that, if I may, just for my benefit and for probably everybody else's benefit, I don't know the level of electrical understanding that people have. I have a little. I don't want to teach me granny to suki eggs, but equally I don't want to go over people's heads. So if people need me to go into any more detail on anything technical, or if they need me to pull back and say, yeah, we know that already, please feel free to shout up.
Yeah, absolutely. You'll probably need more detail from my perspective, because like I say, I am by no means a connections expert. So we're referring to options 1, 2 and 3, and I just want to outlay what they are. So option 1 we'll refer to was the option that was on the table back in February. That was the original option that was discussed with you. Then there's option 2 and option 3. So option 2 is the second option that was mentioned in the email that was sent out yesterday. Option 3 is the option that was not included in the email yesterday for reasons that Ian will come on to and explain. Does that make sense to you, Dom, if we're referring to them in that order, that which ones we're talking about?
Yeah, I think that makes sense. Yeah, thank you.
Perfect. Right. Ian, I'm going to hand over to you for some technical explanation of them.
Right, we have an application from back in February, which was made under a particular nationally agreed way of applying, which gets an absolute minimum of studies done on it. And provided you have 60 amps or less total equipment, and 32 amps or less export, then that can be done, and it gets an absolute minimum of studies. That's option 1. It's still on the table. If you want it, you can apply for it tomorrow anyway. So it's got to be on the table. We, having done the later studies, it's come to our attention that there's actually going to be a voltage issue there anyway. So we would do some de-looping anyway. So we do the de-loop, which actually makes option 3 de-loop and give you what you can have, or back in February, pretty much the same thing. Now there's a slight difference, so that if you go beyond 60 amps of installed equipment, which I need to do the sums and go and get it straight in my head, but it's basically 60 amps is going to be 13 point something, isn't it? We can multiply 230 times 60, whatever that comes out as.
13.8, I think, is the number.
It'll be something around about that.
Was mentioned somewhere, so 13.8, I think, is 60 divided by 230 or whatever it is.
It will be something like that. If it's 16.5, you can't apply. If the 16.5 is what you want, you can't apply under that limited studies one. Therefore, we do the full studies, and at the full studies, we have to do the voltage studies and things like that, which aren't done in that limited. It's a nationally agreed way of doing it. It went through a distribution code review panel of all things to come to that number, and it's something where we accept the risk that we might have to go out and do something. And in this case, we'd actually have to go out and de-loop, but in practice, the cost would be the same to us because it's the same bit of work and the cost allocation is the same. So, but the voltage on your property would still be just over the 253. It'd be 254 at 32 amps export. So the option 3, although you've got more installed capacity, the reason I'm looking over there is because that's where you are on my screen. It's a very wide screen. It's not my normal desk. The installed capacity would be higher, but you wouldn't be able to have the 32 amps export. We'd have to ask you to limit down to the 253 volts, which is, I think, as I recall, it's 6.8. But I would have to go away and just check my notes on that one.
That was the limit that was put on the de-looping option, then, wasn't it? Which then turned out to be slightly lower than what we've got at the moment. So
yeah.
Just so I understand what you said so far, like, are you saying that the G100 option to the one that is the, like, a given, you don't do any checks or anything like that? Are you saying that that's not an option without de-looping because?
Sorry, G100 is the limiting device. That's the standard for the limiting device. It's technically it's SGI 3, which I suspect Sophie will know all about SGI 3. And Sophie will be able to go away and grab the standard and talk you through it if you want a second opinion. So it's an SGI 3 application, and that gets limited checks. It's just the earth loop impedance we check. You're okay on that. That is normally a good guide for the voltage. In this case, it's close, but it's 1 volt out in over 250, but it's still over the stat limits. So that becomes a little bit of an issue, but you can still ask for that, and then we ultimately have to go and sort that out somehow or other. That becomes our problem. But you are limiting yourself then to 60 amps installed, 32 amps export. Given that you then effectively dump all the problems on our door, absolutely legitimately, I might add, that's what the standard says you can do.
But like, to me, that, like, everyone's kind of a loser. Do you know what I mean? As much as there's a part of me that takes great joy that you'll pay for all my stuff, that's not the right thing to happen. And ultimately, you're a public service, so we all suffer if you waste your money on that sort of stuff. Like, I think
it's not.
One of the things
I don't think it's a waste of money in the fullness of time. In the fullness of time, I think everyone's going to have solar on the roof and everyone's going to have a battery in the garage, and so they like well should do.
I think the challenge that the de-looping brings up is the digging up thing. Like, I was sort of hoping that we could have the option of the fast track application up to 13.8 kilowatts without de-looping and stuff. But if you're saying that requires de-looping, that sort of scuppers things a little bit.
That would require de-loop. I mean, you can.
The point I'm getting at, though, is, like, if someone's got to dig up the driveway, because someone's going to have to dig up the driveway, basically, either de-looping or three-phase, someone's got to dig up the driveway. And so the thing I was trying to communicate in the previous email is it seems weird for you to pay to dig up my driveway to de-loop, knowing that then in 5 years' time or whatever, I'm going to then have to dig it up and pay for it for three-phase.
I can help you. I can help you out on that. I can tell you why that sounds weird. It's because we're not going to do that. What we're going to do is we're going to put a little bit of three-phase into the street, which effectively comes from the end of your driveway. If you're standing at your driveway and look to the left, the houses there, it run along the pavement in front of them.
Yep.
They would go into one phase, you're going to another phase, and you're then separated. So we'd effectively be putting a bit of three-phase in there in the front. We wouldn't be digging your driveway up. That would all be done in public, which is why I can turn around, and effectively on that option we put out, I didn't mention de-looping because that's our network. It's in public. It's not your land. It's our cost, our network, public land. But we do it because we have a duty to keep our network in order. If you go three-phase, guess what? We're going to do exactly the same with that bit of three-phase cable in exactly the same place.
But then I dig up my drive.
Then we put a three-phase service on the end of it all the way up your drive. So the difference is, do we dig your drive up and put a three-phase service up it? And that's the only difference between the two in that sense, in a physical sense. So to say, well, if you do it now and then do something else in the future, we haven't wasted anything. Because we're going to do, we might have to redig one joint hole, which is a couple of square meters.
Yeah. So that's what I'm thinking. If we do go for the de-looping, then it would be useful to make sure that the de-looping is done in such a way that when we come to do three-phase, it joins in the right place, if that's possible. Like, I
don't know if you can see that, but I've got the plans.
You've got a blurred background.
Sorry, guys.
There you go.
Sorry, I lost you all for a moment.
Yeah,
that's all right.
So
I did say to Ian, I said if you could bring some diagrams that you can draw on and show, but I think your blurred background's taking it off when you're holding it up, but it is all drawn out, Dom, and we can send you it.
Yeah, so I think they were sent through, some of them, weren't they? I did have a look at them, like the diagrams. There's definitely some mild differences between the local area here. Like some of the property boundaries are not where they're drawn on some of your diagrams.
Do you know how much that surprises me? Absolutely.
Yeah, especially in this part of the country as well, honestly. It's,
and in some ways, it looks like an absolutely lovely area of the world, incidentally, but it does look like an absolute nightmare for digging up roads, because the cables, generally speaking, are in the road, not in the. There's a little bit of pavement on the left-hand side of your drive, and that's where we think we might be able to do it without closing the road. I know how popular we are when we close roads.
Yeah, I think we'll be able to talk to some specific issues we've had on my road over the past year about digging it up that caused massive internet issues as well.
And not only for us, but from your point of view, they'll work out why we're digging the road up. When you suddenly get hold of the solar panels and we've dug the road up and closed it, nobody wants to be there if we can avoid it. There's a little bit of pavement, we can do something with that, hopefully. So would we have to come onto your property driveway, maybe by a yard or two, just to get something that isn't on the road there? And if that worked for you and that worked for us and that worked for the road not being closed, then we might ask to do that. But that's kind of level of it.
We would always fully restore everything back to its original condition as well, though, Dom, if we did dig anything up. We're not just going to leave you with the mess.
I do apologise, because it does sound really petty. I just had my entire driveway resurfaced like last year. So, and it's tarmac and it's cobblestoned. And so if you're going to put like a strip down the middle and put a strip back, that's not quite the same. Would you resurface the entire thing, or because that seems unnecessary? But by the same token, that is putting it back to where it was. It's a mess. It's a mess. I apologize.
That's the kind of thing that once we actually work out what we want to do,
we'll figure out the detail of it.
That's definitely something we'd want to talk to you about on site.
Before we did anything.
Yeah, absolutely. And
like I'm not going to sit here and commit to paying £20,000 for a whole new driveway, but we'll figure out a way around it.
Yeah.
Because that's what we do. There are, and I think this is, I guess, sorry, Ian, I know I'm going off on a little tangent here, but this is fundamentally what we do. Is customers come to us for these connections all of the time, and perhaps we haven't articulated well, and I'm not going to digress into the previous journeys, but our aim is to find a solution that works for you, because you're our customer and this is what you want. You want solar on your house, so let's figure out a way that you can do that fundamentally.
Yeah, I mean, put this in perspective, and not all of them are accepted, and not all of them are for solar or LV or anything like that, but there's about 30,000 between the small works and the major works. So the SGI3 that you had back in February, that was a small works job, as we'd call it. It gets minimal looking at it. The second one's come into my section, which is the major works design. We have a bit heavier look, but between there's about 30,000 schemes go through every year and provide quotes to customers. So yeah, there are always, unfortunately, in 30,000, there are always some that go smoother and always some that go less smooth. And we don't like them not going smooth, but it's something we have to work around. So. Right, what else can I tell you?
Sophie, were you going to come in there with a question? Sorry.
Yeah, well, just so when Ian was saying about the 30,000, then is that just Northern Power Grid?
Yeah, that's customers applying for either small works connections, so your LV chargers, your solar, a little extension, or your major works, which is, multi-million pound kind of.
It's anything from five houses up to several hundred megawatts for a data center or a solar farm or something like that, and everything in between. So
yeah, because I deal with all 14 DNOs plus the independent ones as well, and we do quite a lot of applications a week. It's never ending, and they're just coming more frequent.
Yeah. There's going to be.
Everyone just wants bigger systems.
And then there's all the houses that are out there already that are going to be getting heat pumps as opposed to gas boilers and things like that.
Mm-hmm.
And if let's be generous and suggest that only 2/3 of the housing stock in Yorkshire needs to be changed over, that might be an underestimate. It might be an overestimate, but it might well be an underestimate. That's 2.5 million homes over 25 years. That's 100,000 a year of those as well. Yeah, we're aware of what's going on. So my guys at the moment are looking after about 12,000 applications at the moment. The rest are in small works.
Wow. Sorry, Ian. One more question.
Oh, sorry, and just give me one more sizing for you. We have 2 licenses. There's a dozen licenses, so you can, basically multiply everything by 6.
Oh, wow. And one more question. So are the government or the ENA doing anything with the infrastructure of the grids? Are they going to upgrade them? Are they working on them?
That's definitely a question for Ian.
Yeah, the government are going to do nothing, because the government don't own the infrastructure. We own the infrastructure, and it's for our owners to get their hands in their pockets. Now, that sounds lovely. We are allowed to be in a regulated business, as was pointed out to me. We are a regulated business. We do get the money back, and we get it back in a fairly defined way. And it was 25 years. I think it's currently 45 years, and it's who knows what it's going to be going forward. So I think there's in there that 25 years was right on this time. But effectively, we offer a mortgage facility to the country for the network, and then we get our money back over 25 years, the same way that a bank would. At the same time, we own and operate that network. So it's that sort of arrangement, and that was a real layman's version of what's going on. If you want to get into the intricacies of it, there are PhDs to be had, trust me. So are they going to do anything? No, we own it. We put the money up. We recover our money over time. Is the ENA doing anything? Well, we are the ENA. The ENA is our trade body. In fact, I'm not sure. Is Phil still the
Yes.
chief exec at the ENA? So our president and chief exec is the chief exec at the ENA as well. It's a trade body. Nothing different to that. I turn up in some of the working groups and things like that, and
I work with the other DNOs through ENA.
It's just crazy, isn't it? Because like the government are pushing for net zero, pushing, pushing.
Yeah,
and
not willing to fund it.
No, not willing to fund it.
Well, if they do fund it, it will be direct funding, and I appreciate we've got a representative or an MP of the current ruling party, so feel free if you just want to tell me to shut up. But if there is funding, it shouldn't be funding to us. It should be direct funding and grants and things like that to push a particular technology, a particular direction, and things like that. And we've seen that in the past. It has been stunningly successful, and it was so successful they stopped doing it to some extent with solar. If you remember some of the incentives that there were on solar a few years ago, I didn't get that when I put my solar in. The incentives were over, but what I can tell you is it's still been worth my while. It adds up. And the most expensive thing in kind of unit cost and putting my solar in was probably the scaffolding. Putting twice as much solar in raised the cost of the solar from I think about 7 to about 9 for twice as much. And it's the scaffolding, because once you've knocked off a couple of grand, then actually those numbers start to make an awful lot more sense. So it's. Well, I could talk about this for days, and in fact, I have talked about this for days. They stick me up on national stages and things like this. So I could talk about
it for a long time.
So you had one. I think you had one more question, Sophie, or was that it?
Oh no, that's answered. It was just out to
So to put this in perspective, the bit that you can't see, Dom, or I don't think you can see, is the little bit of three-phase that we'll put in the pavement. That costs between £7,000 and £8,000, and it doesn't for either job. Then to extend onto your property, I think, did we say just over 5,000? It was of that order. I'm doing this from memory.
5,600 or something, wasn't it? I think was the number.
I've got the quote up here.
Yeah. There'll be things like that and things like that which I won't have worked out properly.
6,222 with that.
Right. So that will have been somewhere in the region of 5 before the VAT, just over 5 before the VAT. Yeah. And then if you were just to, if we're just picking up the existing service, there's obviously costs for just jointing that onto the bit we put in. That would be about 1,500 quid. So if you went for just the existing service now and then changed to 3-phase later, you could argue that there's about 1,500 quid that wouldn't be on your books, it would be on our books and therefore the nation's books, I guess, that wasn't used in perpetuity. Is that a good description of it? But that's what I'd love to draw you back to, if I can, is what do you want to do with the solar? Is it for self-consumption? Is it for export?
So
what's it for?
This is what I was hoping to be able to do, basically, is explain to you where I'm looking to get to, and then hopefully you can make the decision for me and pick the sensible option for me. So essentially, at some point in the next couple of years, we will probably be looking to get a heat pump installed. I've had a few different quotes for them, and the sizing for them tends to come back between 11 kilowatts and 16 kilowatts. I have had things range all the way up to 24 kilowatts, and I have had them range down to 7 kilowatts as well. So this is from Octopus, from Era, from HeatGeek. Yeah, so you can see my concern and reservations about
that
heat pump.
Is that output or is that input?
Yeah.
So the heat loss calculations for the house, Octopus did a remote survey and gave 7 kilowatts heat loss. They then came to the house, did the in-person survey and gave a 24 kilowatt heat loss. Heat Geeks came and did a survey and they gave a heat loss of 12 kilowatts. Era came and gave a heat loss calculation of 13 kilowatts. I've just had another local chap come along. He's not put the windows yet in the design, but he's currently getting 14 kilowatts. So basically,
okay, so let's go with the 24 for the moment, because it can't be. I don't think it sounded like I didn't hear a worse number than 24.
That's in my mind. My guess would be it's around the 14 sort of kilowatts or something around. Just because most people tend to convert around 12 to 14.
Let's make. I'm going to make it. I'm going to make it 24, and it'll become obvious in a second. It's because 24 divides by almost anything. And the reason is that in amongst that, if that's your heat loss, that's the thermal rating of the heat pump.
But the heat pump was the efficiency. So I understand what you're getting at. It doesn't consume that amount of electricity to heat the house.
One hopes not. Otherwise, you might as well just have some big electric resistors in the place.
Exactly.
Now the flip side of that is it will be slightly less efficient in the winter if it's properly built and properly installed and things like that. So I'm not a heat pump expert in Stanley.
Let me throw the other parts into this equation. So I went to the heat pump because whenever I would try to get the heating sorted out in the house, and I went to heating engineers and I said, I have 2 wood burning stoves. We run those 6 months out of the year every day, like over the winter months and stuff like that. We have a large amount of roof space. In my mind, solar thermal and the fires into a big thermal store that fits in exactly what I'm doing, fits in with the house, all that sort of stuff. I can't find anyone to do that. I couldn't find anyone to do that. A lot of places suck through their teeth. Everyone says, just go and get a heat pump. Every time I then go and do the heat pump surveys, they come back and they essentially say, great, you can have a heat pump. Your electricity bill is going to double as a result of it. So, yeah, I'm trying to do the right thing, trying to go to the different services and things like that. With the heat pump, they give different things. But anyway, the point is at some point, I'm assuming we're going to get a heat pump because that's all anyone seems willing to do with heating nowadays because of the grants and stuff like that. And then beyond that, we would also look to get an electric car as well. Like for the electric car, I've been keeping an eye on the bi-directional charging. So I would wait so we can get the bi-directional charging so the car can charge the house and stuff like that. My understanding is that's kind of on the horizon over the next year or
you
two.
Already can with some cars.
Yeah, exactly. So there's 2 cars that are doing it, isn't there? I think it's not widely rolled out, so it's still on the horizon. I'm not ready there yet, but like that's what I'm thinking over the next few years, basically. And it's what I want to avoid is doing some work now to get the solar installed, and then come to get a heat pump installed, and you're like, actually, you've got to dig up and do again. And then we come to get the car charger, and like, actually, now we've got to go 3-phase. Do you know what I mean? But by the same token, I can't immediately now plan what heat pump and what electric car I'm going to have in 3 to 5 years' time, because the tech is going to be completely different efficiencies and everything like that. So what would you suggest?
You've got some information there that you've got 2 wood burning stoves. presumably you'll know how many kilowatts your wood burning stoves are, and you'll know if you're burning dry wood or not.
They're being replaced as part of switching over to this. So we'd
So,
have to replace
sorry,
them
yeah,
with
but I'm guessing there'll be 3s, 5s, or 7s.
The ones currently installed are 2 5-kilowatt ones because that voids the air bricks for there. But we would have to upgrade to something that matches the heat loss calculations, which we discussed about, 40 to 20 kilowatts or whatever.
But so it sounds like you are not horrendously uncomfortable around the kind of 5 kilowatt, and they won't output 5 kilowatt unless your wood is dry, kind of thing, and so on and so forth. So it sounds like you're in that kind of ballpark. Incidentally, I am not giving any advice. Joe, point this out. I'm not giving any advice on this sort of thing. I just happen to know because I have a wood burner in my house as well, strangely enough, and we have an EV, and we also have a battery that we charge, and the solar on the roof and so forth. And right, so if you are thinking of running your heat pump at the same time you're charging your car, then
that's what I have to plan for. Essentially, the worst case scenario.
One would, because
the tariff forces it to be that way, doesn't it? So
yeah.
You want to future-proof. You want to future-proof having all of these things installed and all of these things running at the same time, and it not causing a problem on the network.
24, so you're going to get around about. So if you said 24, which is overkill, if you're running off two 5s at the moment, really. It feels
we have got a boiler as well, so I used 2 wood burners, but we have gas central heating for the hot water. The gas central heating, it's a 35 kilowatt gas boiler, combi boiler.
Well, okay, I'm gonna let's go back to that 24 just in case. You should be able to get somebody to install to cop of around 4 these days. It would be assuming you're getting the heating looked at, the underfloor or big radiators or whatever at the same time.
Another challenge, it's a barn conversion. So I don't know if you looked on Street View, but the front of the house has got like a 3 by 3 meter like big stone arch with glass windows and everything like that. So the idea that a heat pump.
Yeah, we looked at Street View. We liked it.
Yeah, exactly. Like it's not the sort of house that a heat pump runs efficiently in, though. Unfortunately, so I think
I can see that
around 3.5, sort of. They're not high efficiency, however. So.
Yeah. So let's say 3.5. You're going to be in around about 7 kilowatts there as well. So it's 7 kilowatts for the car charge and 7 kilowatts for the heat pump.
We have an electric shower as well, which is a 10 kilowatt electric shower. So
would you be intending to continue to use that if you got a heat pump that'll deliver hot water or not?
We would want to keep one electric shower, one mains heated shower, essentially. So we have 2 showers. Yeah, one is connected to the mains, one is connected to electricity, basically.
I'm not going to.
And it changes it a bit, but.
Yeah, I'm not going to include too much for that just at the moment because I'm assuming that you don't spend hours in the shower. It's kind of 10 minutes or something like that,
No comment.
Because that matters because it's the limitation on load is a thermal load and there's thermal lag in there.
Yeah, so it's the time that it's heated up for. Yeah.
So I'm just playing with that. Now this is off the top of my head, so please do not hold me to any of these calculations that I'm just doing off the top of my head as we go. You'll have but let's include a little bit for that. Let's say that there's about 2 kilowatts of effective thermal rise on the cables coming in and things like that in that time. So that was EV, heat pump, shower. Then you'll have another problem. How big a house is it? I've looked at. I can't remember off the top of my head what kind of how many bedroom house is it?
So when we bought it, it was a 5-bedroom, but it's a 3-bedroom now technically. So.
So it's still going to be in that kind of ballpark region. So you're probably going to need about another 1 to 2. I'm going to say 2. Let's be 2 kilowatts ADMD to look after ADMD after the diversity maximum demand. So not all your kit runs at the same time. Therefore, we diversify it. So your maximum demand after diversity. To be fair, that's on our system. That's not on your. So it might be a bit more, and but it's going to drop. So let's assume that's not a million miles away. So yeah, okay, probably on the standard 80 amp, 100 amp cyclic single phase connection, you're probably going to be okay.
That means I would like to avoid three-phase, and we should be able to avoid three-phase. You said it here. I'm going to hold you to it. It's all recorded.
Yeah, it's a good thing I also said don't hold me to anything.
But at least
in
we're on the
fairness, right,
same. We're heading in the same direction
Yeah.
now, guys.
Is
I
there a way
think
that I could confirm that? I know that obviously I don't expect you to confirm it now. I don't want to hold you to it, but I also don't want to end up in a situation where I assume, okay, we don't need three-phase, and then in 5 years' time, that, you know, how could I confirm this? Is it possible, or do I just have to take the risk? Like,
shall I do it another way?
Go.
The risk you're taking is that you get to keep the money in your pocket for 5 years. I don't think that's the worst risk to take.
that's what I'm getting at, though. Like, but by the same token, I would rather get it out the way now, when I'm at a time where financially it's a lot easier and better for me to be spending large amounts of money, rather than putting my dependencies a little bit further down the line, if that's possible. I think, like, I appreciate what you're saying, though. It sounds like it's not
I'm going to be
crazy thing that I could get under. I could get everything in and not have to go three-phase. I'm not holding to this. I'm not, you know. But
yeah.
it does sound like my hypothesis that I'm going to have to go three-phase at some point. I should root that out a little bit more and test it a little bit better.
I would. It's worth testing. The problem is we're
that's not your job.
If we have expertise, our expertise is in the network, in the system. So on the other side of the meter from you, and there are other people, and Sophie, you might feel you are, or you might feel you know some people who are experts on the electricity on dumb side of the meter. And certainly, obviously, for the solar side, you would feel you were, but it's quite difficult now. I know that the IET are currently looking at the wiring regs and rewriting some of the diversification between things, because new loads like EVs, heat pumps, solar, batteries have all arrived, and the wiring regs haven't really fully understood them yet in terms of how those would affect things. But I'm not an expert on that.
I'm
One of
not
my colleagues
an expert in anything. Sorry, Ian, I'll just come in there.
Yeah, no worries.
I just think I get what you're saying, Dom, and you want to future-proof it, but you want to know the odds of needing to future-proof it. And I think, personally, I don't think we know what's going to happen in the future, unless Sophie knows someone that can do that analysis. I don't think we know. And
it's hard to.
I would prefer to prepare for the worst and come to not need it, rather than need it down the line when it might be more troublesome for me to do, if it were me personally. I've got solar, I've got an EV charger and 2 EVs, heat pumps probably next on my list. If I was in your situation, I would probably personally do the 3-phase now, like you say, to not have to have the upheaval and the cost in years' time, because we can't guarantee that you would not ever need it.
Yeah, it's not your place to guarantee it as well. I appreciate what you're saying there. I feel like I'm putting you in a bit of a spot that you don't want to be in, where I'm asking for advice on something that you're putting your hand up and saying that
we can give you our opinions all day, and Ian and I will sit and do this all day long.
Oh yeah, I'll tell you one other reason you might prefer the 3-phase. And that is 16.5 kilowatts in or out, fill your boots.
That's kind of my assumption. I think the challenge I have with 3-phase is then how do I get to it in such a way that I've got the extra cost for it, and is it genuinely needed? I guess because it causes other implications for, like, the solar design, for example. I'm aware that we've currently planned the design to use single-phase inverters, but my understanding is the way that 3-phase inverters work, because there is Fox do 3-phase inverters now. And my understanding is they will do that distribution to meet the 16 amp variation you need and stuff like that. But I need to know that beforehand, because if I go single phase now and then go 3-phase later, we then have to update the inverters. And you'll have similar problems with yours, Joe, if you have to go 3-phase.
Yeah.
And you still
We've done that before with customers. That's happened before, where they've upgraded it and we've had to swap out the inverters. And
again, it's another unexpected cost further down the line.
And the other thing I'm thinking is that with the 3-phase, the thing that's like, I don't feel incentivized to do it now, because my assumption is that going forward, a lot of people are going to need to do this. So there is going to be assistance for it. And so there is that, like, a bunch of trade-offs, again, a tough decision that I've got to make, with a bunch of different things that could or couldn't happen and things like that. It just feels like there's not an optimal one. And I feel like everyone's saying that we will have to use 3-phase, and at some point in the future, there'll be assistance of it. And I'm just going to be kicking myself if I throw a load into it now, and then a few years down the line, government comes back and says, "Well, upgrade it for free," or something like that. But They won't do that with it.
Yeah, I mean, I'm on one of the ENA working groups on LCT, strangely enough, and there's a subgroup working and looking at three-phase on that. The general feeling is for new properties, three-phase probably won't be needed because they'll have the insulation and things like that. They may even get a ground source, which again might have its benefits. For existing properties, larger existing properties, particularly poorly insulated ones, there may be some need, but it's a marginal call. The other thing that is worth just noting, I don't know your background. I don't know at all about what you know about these sorts of things or what you don't, but three-phase motors run more smoothly than single-phase.
I didn't know that. That's interesting to know.
Because
Repeat that again, Ian, please.
A three-phase motor has less vibration associated with it than a single-phase motor.
You've got more magnets around it, right?
But essentially, if you think of single-phase, it just goes this way, that way, this way, that way, this way, that, and because it's spinning, if it's timed right, it keeps going round. A bit like pedaling a bike. You know, your foot just goes up and down, but the cranks go round. But three-phase, it's pulling from three different directions, so none of those are actually directly opposed to each other. So you get less vibration in the motor. Now, it's marginal, and when it's new, you won't notice a jot of difference. But if you walk past old fans and that rattle and things, that's because it's slowly being vibrated. It's strangely enough at 100 hertz, not at 50 hertz, for however many years. So the question, I don't know if that's going to be an issue with heat pumps, because they might all be inverter driven and not AC motors anyway. But you know,
that's an interesting thought.
That's one that I would play with and talk to people who do heat pumps. The other one, if you're not doing heat pumps today, and I noticed that there have been some changes in the last couple of days, it might make buying things from Europe that little bit easier. You never know. Certainly Germany, I think, is generally three-phase. I think Scandinavia is generally three-phase. The heat pumps that are built for those markets will be three-phase heat pumps. So because you're buying out of a bigger market, you should get a cheaper price for the same bit of kit, better performance for the same money, whatever it might be. But that is the sort of thing to talk to heat pump suppliers. Sorry, Sophie, I don't know if you guys are doing heat pumps as well.
We don't get involved. It's something we looked into a couple of years ago, and we purely just want to be solar PV specialist. When we looked into it, the amount of work involved for an air source heat pump, and it's not that when it's Christmas, obviously, and it gets cold, you're getting call out over Christmas. It's just not.
Yeah. They use them in sub-zero temperatures in Scandinavia all the time. It just depends how you design it and how you install it. So find yourself a good installer, and it might be that Sophie's able to point you in the direction of somebody they would trust, and have those kind of conversations. That'll help you fix your mind. But yeah, I can see that there are some benefits to having three-phase, in that it just takes a lot of variables out of the equation for you.
Essentially. But then the challenge of going three-phase now is the extra costs and the incentives, and is it going to be easy to do it later, or are we to do it now? I'll be completely transparent with you. Like when I came into this meeting, is what I was hoping and assuming and sort of looking to go away with was accept the options that are available on the table, and then I was hoping that we could figure out exactly the magic number to avoid digging anything up, the 13.8 kilowatts, verify all the inverters fitting under that, not really have to dig anything up and not really have to worry about three-phase. But you've kind of convinced me to worry about three-phase now. So
I think the other
way to think about it. But yeah, that's.
If I recall correctly, I don't have the numbers in front of me, but I think to not need any digging up at all, then it was going to be an export of 5.5.
So, well, it's what I was meant by that. Sorry, is I didn't realise there would be the delooping needed for the fast track application. But if the delooping doesn't involve the digging up or anything like that, then I could consider that. One thing that would be useful to understand, like so, the 32 amp limitation that's as part of the fast track application. What actually happens if someone goes over that? Because as I said, Cortec was adamant that if I generate more, I can export more than that. It's fine. It'll be configured this way. I've run Northern Power Grid. I've checked it all. Blah blah blah. So he was going to come and potentially look at this.
Who's going to come and test it?
A number of things can happen. We've seen it. We've seen it happen. It can burn the inverters out and the
That's what I said,
voltages.
Yeah, but if the inverter's sized for it though, and it exports back to the grid, like from your point of view, Ian, what thing bursts into flames when that happens? Is it my fuse box? Is it my neighbour's cable? Is it like
Well,
the
hopefully
inverters,
nothing.
the cables?
Hopefully nothing bursts into flames, because hopefully the first thing that happens is that some relays that are built into your inverters say the volts are too high. I'm cutting out.
Yeah, it's built into the inverter, Dom. And we set it to cap at that. We've had a custom.
So I do understand that. I do understand that it's set in the inverter and we set it to that limit. I'm just trying to understand, because my takeaway from the interactions with Cortec is they were quite explicit in that, like, I don't need to worry about that sort of stuff. If I generate more than that, it's not configured in that way, and that sort of stuff, basically. Like, so I just wanted to understand that if that had happened and I'd tried to export more than what was there, I can see the arrangement of the inverters and stuff like that.
There will be high volts on your system and high volts on your neighbour's system. So you'll be causing them issues as well. Now, would it be high enough that it tripped everything? Potentially, but not definitely. You never know until you find out, kind of thing. But you could end up tripping stuff in their house. You could end up causing damage in your neighbour's house, or indeed in your house. That said, I would expect if it's properly installed, that the inverters would limit, and if they fail to limit sufficiently, then the voltage limits in the inverters would kick in as well, and prevent anything going wrong. Now, beyond that, I think it would be unreasonable for us to talk too much about Cortec. Cortec, given that they're not on this call.
No, I understand.
And that said, I don't know how often. I mean, let me put this in perspective. My own installation is about 7.2 kilowatts. It faces east and west.
Yes.
It looks like yours would face northish and southish.
All directions, essentially.
All directions,
so half of the array is north facing, almost directly north facing places.
So I suspect once you knock off what you're doing in the house, the amount of time that you're actually going to be exporting anywhere like that region, given you've got a battery that you'd be charging as well, and then using that during the night, I don't think it's something that's I mean, it might be great to have the ability. In fact, I've got the ability to export 8, even though I've only got 7.2 installed. Well, it was what worked around there, and I thought, I'm having that before somebody else does. And I was also very careful that my name was nowhere near that application, because that would have made me feel compromised. So that was done by the installer. But I don't think there's going to be a particular issue, because I don't think you're actually going to export a huge amount, except absolutely in the middle of the summer when it's a day like, there's a few clouds even in the sky today, wall to wall, cobalt blue skies kind of thing. In the middle of the summer, maybe. But even then,
in the middle of summer, I was assuming there will be times where as much sun as possible is getting to them. The heat pump would never ever be running. The battery is already fully charged. There's nowhere else for it to go, essentially, apart from back to the grid or whatever. But I appreciate that.
Some potential there. But I mean, if you then end up with an EV, you can set that to charge with the
excess.
Yeah, what I do with mine. If I'm working from home, I just trickle feed it into the car all day, any excess.
Yeah, and that's gonna have a 50 kilowatt hour battery plus. There's not many with less than 50 kilowatt hours these days. So you got plenty to sink that into. So I wouldn't necessarily think it's going to be a sack load. I think what's more interesting is if you end up needing that heat pump and EV charging and power shower and whatever else in the fullness of time. I think that's what's going to push you towards.
I mean, that's been my hypothesis the entire time, and I've been asking everyone at various steps of the way, am I going to need to go 3-phase in future? And everyone was sort of, you probably don't need to worry about that. And so when we then did the application and you came back and said, you can have it, but you've just got to go 3-phase, I'm like, I've asked everyone if I need to do this, and you all said I wouldn't. Like, what's going on?
The thing that's driving you to go 3-phase, the thing that absolutely makes it go 3-phase is if you want to be able to export 16 kilowatts.
Yeah, so
it's going to be 3-phase to keep the voltage down. That's not a thermal limit. That's a keep the voltage down.
Yeah, and that's just and is that just for the export then? So like, if I don't want to export a huge amount, if I get the heat pump and I get the car, and I can be confident that I'm never going to need to export a huge amount, I don't then need to go 3-phase. I can just do that with a D-loop setting and things like that. Then, yeah.
Pretty much. I mean, there are some niceties around the level at which the export is set on G100 and the total installed capacity. And again, Sophie, I'm happy you give advice on that as well. But that's the G100 settings basically. And I've off the top of my head, I cannot remember. I have people who sort that sort of thing out for me, and they don't forget it because they're doing it every day. But I would actually have to go and get the standard out and check. So that was why with the, I mean, it's effectively it ties back in with the 60 and 32 amps if you think about it.
So assuming I go for that option and we go for that D-looping, that'll mean you run 3-phase essentially to the top of my drive and just then connect into my existing single-phase bit to my property. If we do that, then that also then means if in 5 years' time, you know, I can export huge amounts, so I do need to go 3-phase. The only bit of remaining work that will be needed is essentially just digging across my drive and joining onto your tails on the road. Yeah. With that in mind, when I've looked at this and thought about this, we kind of have an idea of where we would want to dig up and put the 3-phase, where we would want to join your tails on and stuff like that. Is there any way that we can work with you to get the de-looping done in such a way that it might terminate where we might want to put 3-phase in the future? Does that make sense?
Within reason, I don't see.
You don't get a choice, sort of thing. Or?
Yeah, within reason, I don't see a problem with that. If it's another kind of 5 or 10 meters of digging and things like that, then we might really. But if it's kind of like there or there and it's the same sort of distance, then we're not going to get overly worked up about that. We just need to make sure it's chased through and everyone's got the right bits and pieces. The other thing that's going to be of interest to both yourself and Sophie is, I'm assuming you like to start sticking the solar on your roof as fast as you can while the weather is good. I think the other thing that might be doable is if you are willing in the interim just to limit it to 5.5 export until such time as we get the de-looping done, then that would be something that can be done. You need to change the settings, obviously, when we get the de-looping done, but that just keeps everybody safe. But it allows us to work around that.
That's very good and a nice thing to offer. I appreciate you probably don't have to do that. I don't know if you do or not, but it's appreciated either way. It obviously gives us a path forward and stuff like that.
We do try and make it easy for people if we can. I know it doesn't always come across that way.
I know. Listen, I'm conscious we've overrun with time and I'm not sure what commitments other people have got. I know I do have a hard stop because I've got another 2 o'clock. What I'd suggest is we close the call now. Dom, you go away and have a think about what we've talked about earlier. I am more than happy to rearrange another call with the 5 of us or just with myself and Ian if you'd be happy to do that, or you and Ian can speak freely as much as you'd like. I'm sure, you know, Ian can talk about this stuff all day long, I'm sure. I'm sure.
One last thing, just while we are on absolutely clear, because we're on the tape, so let's be absolutely clear about it. That 5.5 is my recollection of what the right number was to limit it in the meantime. Please, if it turns out to be 5.2, please don't sue me.
Ian said 5.5, sorry. It's a safe place, Ian, but
we'll have to go away and just check, but I've seen the sums, and 5.5 is a number I remember. It would feel like it's about the right sort of region. It can't be less than 3.68 because everyone's allowed that. That's
you'd be surprised, Ian. I've done some DNOs in the SP Energy networks are declining a 3.6.
I mean, I'm not going to.
That's another conversation for another day.
I was referring you to ESQCR, and I think it's Reg 22, freely available on the internet.
Say that again, Ian. You broke up.
ESQCR 2002, Reg 22, I think it is. But it's the one that is parallel connection of generation. You're Googling it now.
Could you send that to me on email?
We can certainly. I'd see no problem with sending you the bit of the ESQCR that refers to connecting parallel generation. That seems entirely reasonable.
Yeah.
Now,
Thank you.
what else is in the background with, was it SSEN you said, or SPEN? Joe, you need to run, don't
SP
you?
Energy Networks.
Yeah,
I
I don't
but-
have a clue what
No.
they're doing, and I will pass no comment on what they're doing. All I can tell you is that's what I think the law says.
Listen, I'm going to close the call there. Dom, I'm going to leave the ball entirely in your court. You go away and think about it, and then you let me know what you want the next steps to be. Okay?
Yeah, no, I appreciate that. I'll get on a quick call with Sophie after this if you're available, Sophie. I don't know. We'll have a quick chat and
Yes.
see what works out and see if we can get something.
course.
Going through. I'll drop you an email just saying this is what we'd like to do. Does this work? Can we shuffle these things around? And we'll go from there. Yeah.
And if you need somebody out to kind of walk around your driveway and point at things on the ground, we can have somebody out to do that as well. It's no problem.
It would be useful to have a chat at some point about some of the other sort of falling outs and issues we've had about like some of the response times, some of the original deadlines, some of the good intent, that sort of stuff. I hope you can see that, you know, we're all trying to work together. We're all, you know, working towards the same goal.
And this is what I said, Dom. This is, to me, this is twofold. It's one, getting you the connection that you need, and Ian will be looking after that. Secondly, from me, it's about the learnings as to what's gone wrong thus far and what I can do to change things to make it better for all of our customers going forward. So I'm absolutely not lost interest in that. That's high up on my agenda.
Okay, thank you.
Fab.
Thank you.
All right, lovely to meet you all.
Nice to meet you.
Yeah.
Thanks very much.
Thank you.
I
Bye.
appreciate it. Cheers. Have a good one.
Bye-bye.
Bye-bye.
Oh, thanks.